Section 4.4, division of polynomials. So we see a plus b over c is the same thing as writing at a over c plus b over c. If we see a minus b over c, it's the same thing as writing a over c minus b over c, respectively, that c does not equal 0. Remember, 0 in the denominator does not exist at this time without taking the limit of the function. So example 1 says 3x to the fourth minus 6x cubed plus 9x all divided by 3x. So they want us to rewrite this using the division rules. So we become 3x to the fourth over 3x minus 6x cubed over 3x plus 9x over 3x. So first thing I did is rewrote it as individual fractions. And then we're going to apply the rules from 4.1 quotient rules. So when we look at our pieces, 3 and 3 cancel out. Bases are the same, x to the fourth over x. 4 take away 1 means I have 3x's left over. Minus sign. 6 divided by 3. 6 divided by 3 is a 2. 3x's took 1 away, I have 2x's left over. Plus sign. 9 divided by 3 is a 3, and then the x and x cancel out, so it goes away. So we have x cubed minus 2x squared plus 3 left over. When we look at b, they gave it to us in forms of parentheses side by side. It says 10c cubed d minus 15c squared d squared plus 2cd cubed. And we're dividing it everything by negative 5c squared d squared. So rewrite it in form of quotients. So we're going to write 10c cubed d on top of negative 5c squared d squared minus sign 15c squared d squared on top of negative 5c squared d squared plus 2cd cubed on top of negative 5c squared d squared. The reason I wrote it this way is so that in case of sign changes, you can see them. So it's a positive 10 and a negative 5. 10 divided by negative 5, that is negative 2. C's, the bigger numbers in the numerator. So 3 C's took away 2, I have 1 of them. D's, the bigger numbers on the bottom. So 1 take away 2 means I left a D in the denominator. Now we see a minus minus situation because it's minus minus becomes a plus sign now. 15 divided by 5 is a 3. C squared and C squared cancels out. D squared and D squared cancels out, but I'm going to write it as 3 over 1 just to play with the other fraction that we have. Plus and minus sign makes minus sign. 2 divided by 5 does not reduce, so I'm going to write 2 on the numerator, 5 in the denominator. C1, and I have C2 on the bottom. 2 is bigger than 1, so 2 take away 1 means a C is in the denominator. D's, 3 and 2. 3 is bigger than the numerator, so 3 take away 2 means 1 in the numerator. And there's your reduction. So long division. The definition says if the divisor has 2 or more terms, must use long division. If the divisor has 2 or more terms, it must use long division. What does that mean? The divisor is what you're dividing by. So say I had, for example, hypothetically, 3x to the fifth plus 7x third minus 2x plus 7, and I'm dividing this by 3x squared minus 4x plus 1. There are more than 3 terms. There's 3 terms, but the exponent is a value of 2. When the exponent is more than a value of 1, you have to use long division. If the exponent of the leading coefficient is more than 1, then you're going to use long division. If it is not, then you would use synthetic, and I'll explain that in a little bit. Okay, so in this problem it says 6x cubed minus 10x squared minus 14x minus 10 divided by 3x minus 2. A minute ago I said long division. If you have the leading coefficient has an exponent of 1, then you can use synthetic. But because there's a coefficient attached to this variable, it's not a coefficient of 1, I would not recommend it unless you like working with fractions. Okay, so first thing we're going to do is long division. Think of back into your elementary days of doing long division of a number. So like if we wanted to do 5 dividing into 127, you would write your 5 on the outside, what you're dividing into on the inside of the fraction bar of your piece, and then you would go from there. So you're going to do the same thing. So I'm going to write 3x minus 2 on the outside to your division bar. And make sure that your values are in decreasing exponents. Power of 3, power of 2, power of 1, no variable, we're good. So I'm going to write 6x cubed minus 10x squared minus 14x minus 10. So now comes the fun part. When you're doing long division in polynomials, you're looking at the leading coefficient of each piece. So I'm underlining 6x cubed, and I'm underlining 3x because that's what we're dividing by. So we're going to say 6x cubed over 3x. That reduces to 2x squared. 2x squared. When I look up my pieces, x squared is attached to the negative 10. So right above the negative 10, that is where you're going to write 2x squared. And then you're going to think of multiplying back down. So I'm going to put an imaginary multiplication dot is in the corner. 2 times 3 is 6. 2 x's and then one more makes it x cubed. 2 times negative 2 is negative 4x squared. Draw a fraction line. And then you are going to change the signs of the bottom because I'm multiplying by subtraction. So this becomes negative 6x cubed and this becomes positive 4x squared. So let's look downward. 6 minus 6 cancels out. That's what you want to see. Short $10, but I found 4. I'm short 6x squared. There's your first leading coefficient now. Now notice we had 2 terms that we're dividing by, so we need to have 2 terms to work with. Since it's negative 6x squared, you are sliding down negative 14x. So now we have 2 terms and 2 terms. Again, remember, leading coefficient, and this time the leading coefficient is going to be negative 6x cubed. Again, I am still 3x. That is still was the first piece. So now we're going to do negative 6x squared divided by 3x. That reduces to negative 2x. So negative 2x is going to sit on top of the negative 14. So I'm going to write negative 2x. And we're going to apply the same thing we did on the last one. Negative 2x times the 3 makes it negative 6x squared. Negative 2x times the negative 2 makes it positive 4x. Again, change signs of bottom. So I'm going to become positive 6x squared and negative 4x. Again, negative 6 and positive 6 cancels out. I'm short 14, short another 4. I am short 18x. Remember, we need to have 2 terms, so I'm sliding negative 10 down. Here's our new starting term. It's negative 18, and again, we're dividing by 3x. So we have negative 18x over 3x. That results in negative 6. So I'm going to write negative 6. So negative 6 times 3, that is negative 18x. Negative 6 times negative 2, that is positive 12. Again, change the signs of bottom. So I'm positive 18, negative 12. Negative 18 and positive 18 cancels. Negative 10 and negative 10, negative 12 makes it negative 22. This is our remainder. So back in your elementary days, you were told to write the remainder. So in polynomials, it's a little bit different. So our numerator line is 2x squared minus 2x minus 6. So your answer choice is going to be 2x squared minus 2x minus 6. And then because it's a minus sign, you're going to write minus 22 on top of what we were dividing by, which is 3x minus 2. This would be your result. If you did synthetic division, you can come to the same situation, but it requires you to reduce your answer. And you're dealing with fractions, and students don't like fractions. Example 3 says 15x cubed minus 4x plus 9x to the fourth minus 5, all divided by 3x squared minus 4. Okay, so if we're using long division, and we're going to have to because it says 3x squared, it's power of 2. First thing we need to do is rewrite this and place any zero holders. So if you are missing exponents, you're going to place a zero holder for that piece. So first thing, power of 3, power of 1, power of 4. Power of 4 has to come first. So I'm going to rewrite this with 9x to the fourth first, followed by positive 15x cubed. When I'm looking, I'm missing the power of 2. So I'm going to put plus 0x squared. The 0x squared does not have anything affect your problem. It's just there as a place value holder to know where it's located. Then we have a minus 4x, and then a minus 5. And then the division one, we're dividing by 3x squared minus 4. So again, 3x squared plus a 0x as a placeholder minus 4. It's going to make your math a little bit easier. So now we know what we're dividing by and what we're dividing into. So we're going to set up our piece. So we're going to write 3x squared plus 0x minus 4. And I'm dividing into 9x to the fourth plus 15x cubed plus 0x squared minus 4x minus 5. Okay, so again, remember, leading coefficient. So we are starting with a 9x to the fourth, and we're dividing by 3x squared. So we have 9x to the fourth over 3x squared. That reduces to 3x squared. And the reason I had to do this is because when we look at our problem, we didn't have a x squared piece to sit on top. That's why that placeholder is there. So 3x squared is going to sit on top of the 0. So we're going to write 3x squared. Again, remember, imaginary multiplication dot in the corner. You're multiplying down. 3 times 3 makes it 9x to the fourth. 3 times 0 is going to be 0x the third. 3 times the negative 4 is going to be negative 12x to the second. Remember from the previous one, you change the sign of the bottom. So I'm going to become minus, I'm going to become minus, I'm going to become plus. So 9 minus 9 cancels out. 15 minus 0, it's still 15x cubed. 0 plus 12 is now positive 12x squared. And then slide negative 4x, so you have 3 terms since we're dividing by 3 terms. So now here's our new start values, 15x cubed, and again we're dividing by 3x squared. So we have 15x cubed over 3x squared. That reduces to 5x. So I'm going to write positive 5x. And again we are multiplying diagonally down. 5 times a 3, that is 15x cubed. 5 times a 0 is 0. X squared. 5x times negative 4, it's negative 20x. Remember, again, change sign of bottom. So I'm going to become negative 15x cubed, negative 0x squared, positive 20x. So 15 minus 15 cancels. 12 minus 0, it's 12x squared. Negative 4, positive 20 is positive 16x. And then slide down negative 5. Last leading coefficient is 12x squared. I'm dividing by 3x squared. So we have 12x squared divided by 3x squared. That results in the value of 4. So I'm going to write a plus 4. And again, we're multiplying 4 times 3. That is 12x squared. 4 times 0, that is 0x. 4 times negative 4, that is negative 16. And then again, remember, change sign of bottom. So I'm going to be minus, I'm going to be minus, I'm going to be plus. So 12 minus 12 cancels out. 16 minus 0 is 16x. Negative 5, positive 16 is positive 11. Now notice that the power of the x is power of 1. What we were dividing for is a power of 2. When the power of the remainder is smaller than what you're dividing by, you are done. This is the remainder. So your answer is going to be 3x squared plus 5x plus 4 plus 16x plus 11 divided by 3x squared minus 4, your original division piece. This would be the final product piece. Synthetic division. It can only be used when the divisor is in the form of x plus k or x minus k, where k is an integer. You will only be using the coefficients of each term. If you are missing a power, use a placeholder of 0, like we did with the long division. So in this example, it says 3x squared minus 14x minus 10 divided by x minus 2. Okay, what I'm dividing by, x is by itself, I have an integer. K is my integer. 3x squared minus 14x minus 10, I'm not missing anything. So synthetic division, it is basically the division bar flipped the other way. So first thing we need to do, x minus 2, you said equal to 0, so we're saying x is 2. You need that for your problem. So we're going to write positive 2 on the outside. I flipped my division bar. Notice I left 2 lines. Now we're only using the coefficients we have. If we're missing a power, we place a 0 for that power. Power of 2, power of 1, plain number, we're good. So I'm going to use a 3, then a negative 14, and then a negative 10. This is what synthetic division means. First step, you're going to slide down the first number. So I did an arrow and 3 came down. Then you're going to multiply diagonally with the outside number, then add down, and 3 repeat until no more parts. So diagonally, I am multiplying by the outside number of 2. So I'm saying 3 times 2 is 6. It's a positive 6, and we are adding down. So short 14 found 6, I am short 8. Then you are multiplying again diagonally by the 2, because that's our outside number. So negative 8 times 2 is negative 16. Add down, we get negative 22, which is our remainder. Now comes the variable pieces. So let's look at what we started out with. We had a power of 2, and we were dividing by a power of 1. So exponent of the leading coefficient divided by the exponent of the divisor. So leaves us with, so we see x squared divided by x, it means plain x. So this 3 has a plain x, minus 8. And then minus 22 divided by what we were dividing by, x minus 2. There's your answer. Now, question. Can you use long division? The answer is yes. If you feel comfortable using it, then do so. You don't have to use synthetic. It's just a shortcut to long division depending on how pieces are. Example 5, it says 5x plus 4x cubed minus 6 plus x to the fourth. And we're dividing by x plus 3. Since x plus 3, x is plain, 3 is our integer, synthetic division would be the route to go. But before we can start, we need to put everything in decreasing power and make sure that we are not missing pieces. And so we're placing zeros. So power of 1, power of 3, plain number, power of 4. Power of 4 comes first. Then power of 3. I'm missing the power of 2, so I'm going to put 0x squared. Power of 1, which is your 5x, plain number. And then dividing by x plus 3. Remember, before you can start the problem, you're going to take x plus 3, set equal to 0, so x equals -3. That is what we're using to use for synthetic division. That is your outside piece, -3. And our pieces. So now, power of 4 has a coefficient of 1, so I'm going to write a 1. Power of 3 has a coefficient of 4, so I'm going to write a 4. Power of 2 has a coefficient of 0, so I'm putting my 0 placeholder. Power of 1 has a coefficient of 5, so I'm writing my 5. And then you have your -6. Again, remember, first term slides down, so 1 comes down. We are multiplying diagonally with the outside number. So it's 1 times -3, there's my -3, and we add down 4 minus 3, positive 1. Diagonally, we multiply 1 times a -3, and we get -3. We add down 0 minus 3 is -3. Multiply again diagonally with negative, so -3 times a -3 is positive 9. Add down, we get positive 14. Multiplying diagonally, so positive 14 times -3, that is -42. Add down, we get -48 as our remainder. So now remember terms. Started with x to the fourth, and we were dividing by an x. So we are x cubed for our term pieces at the beginning. So we have 1x cubed, positive 1x squared, minus 3x, positive 14, minus 48 divided by x plus 3. Synthetic basically means if you started out originally with a power of 4, you're going to start with a power of 3, and you're just decreasing powers down as you go.